Greetings, CS240 students. This video will cover the idea of instructions and instruction execution. The previous two videos covered data and registers, data being kept in memory. And the PDF accompanying this video has a slightly different program, slightly smaller than what we're going to show here. And I think I can show everything just from inside of the SASM IDE. So the main idea, here is your data that we dealt with before. A byte, 2 bytes containing 2 ASCII characters, a D word containing a single number. The program is going to be in memory also. So the program is data. It's bytes with bits inside of them, numbers inside of them. And these numbers happen to represent instructions. So the computer, when it sees certain bytes, it manipulates the data in certain ways. It has a register called the instruction pointer. It's EIP. And the instruction pointer is going to be a finger moving down the program, one instruction at a time. And there are instructions like if statements and things like that, which will move the instruction pointer in various other ways. So what we're going to do right now is put our finger on this program and trace through it and see how the instruction pointer moves and how the data in memory and the registers change. So I'll start by building this program. That's compiling it, and we will turn on the debugger, and then we'll use we'll start executing. The first thing I want to mention is here's the finger. So they're illustrating the finger. This is the instruction that's about to be run. And I want to show you right now, we can show registers. Remember we saw the registers before. I want to draw your attention to EIP. This is the location in memory where that finger is. So your program is at this address in memory. It looks like a big hex number. It is. I'll also show you that the EAX register contains a 1, and the EBX register contains some other stuff. And this is just whatever CRUD happened to be in the registers when your program started. You remember your registers are your temporary variables, right? That are built into the hardware. So if we, in the debugger it's called step over, we will execute one instruction. And you'll notice EIP has now incremented a little, it's gone up a little bit. The next thing we're going to do that again, and I want you to do look at EAX and EBX. These next two instructions move a 0, and that's just the value of 0, into these two registers. So you'll notice that EAX right now contains some number, and we go one instruction down, the finger moved, EAX is now 0, and EBX contains some other number, and we going to move that finger by one more instruction. Notice EIP down here ends in 97. EBX contains that stuff. We go one instruction. EIP has moved to 9 Charlie. The EBX now has 0 in it because that's what the instruction told us to do. And really, that's all that happens. The computer, it's called the fetch execute cycle. It's called fetch because the bytes where that finger is pointing, where EIP is pointing, need to be fetched out of memory. Then the computer executes whatever instruction that is, and that causes memory and registers to change, and then the finger moves. So fetch, execute, fetch, execute, fetch, execute. That's the way that works. So we've seen putting zeros into registers. The next thing we're going to do is remember foo over here had the ASCII HI, and I'll show registers here for a moment. I'll show memory for a moment. You'll remember this from the earlier videos. And that was foo. Here we declared it to be 2 bytes containing HI. Over here we're showing it in hex as 6869. I could also show you as maybe that's the wrong one. Here we go. There's 2 characters, H and I. That'll show you HI right there. And then bar contained a number 1005, which is that in hex. And there was 1005, which was 3 easy dog in hex. So that's what's in our memory right now. And we're about to do this instruction, which is going to move the data which is at the location foo. So foo is a label pointing to a spot in memory. So it's going to grab 1 byte of data from that spot in memory and move it to AL. All right? So right now that's an ASCII HI, and you'll remember in hex that's 68 and 69 in 2 bytes. We're only going to grab 1 byte from foo. These brackets, these square brackets, are the way you say in this assembler that you're going to be touching memory. So if you see those square brackets there, that means you're actually going into memory to do something. So remember, EAX contains a 0, and AL, if you look at the register picture, is bottom of the right-hand part of EAX. We'll go by right now 1, and now here is a hex 68 in EAX before it was 0. Here's the hex 68 that was in memory. I'm going to go one more instruction here, and that's going to load our number that's in bar, which is not 1 byte, but here we're going to move more bytes. So this is actually going to move 4 bytes. Okay, and here we are. Here is 3 easy dog. Here is 3 easy dog in memory. It's now in EBX. And we've moved our instruction pointer, our finger over here. This next instruction is a little bit of arithmetic. Inc increments a number. So this 68 in hex should become 69 when we execute the next instruction. That's 69. And then the last instruction we're going to do is a move again, and this move is going to put the data which is in that register back into memory. The brackets indicate that. Think of this move as kind of like an assignment statement in a high-level language. So here it was assign AL equals the data in foo, EBX equals the data in memory at the location bar, and now it's going to be the memory at location foo is equal to AL. So these move instructions are written in the same order as an assignment statement. So going back up to memory here was 68, and AL now has a 69. We'll execute one instruction, and the finger moves. There is 69 in memory. It's now going to be II instead of HI. And the rest of the program is just going to return. So that's the main thought here, the fetch execute cycle, and EIP moves, and the data is manipulated by the different instructions. Thank you.